So now we're going to try and see how can you factorize a cubic expression or a cubic equation, right? We've been factorizing quadratic equations for a long time. We know how to do that using either the quadratic formula or completing the square or even factorization by inspection. It's something we've been doing for a long time, right? So now we're trying to figure out if we can actually teach one another how to factorize anything that is cubic. Before we even go far, a cubic is an expression or an equation that has got the highest exponent as 3. It's a third degree order kind of question. So when you factorize it, it will always give you 3 factors like this. It's going to produce 3 factors all the time. Right, there is a formula for factorizing any cubic expression, but it's very complicated. So the easier methods that you can use involve either long division method, or you can do it using monkeys eat apples plus bananas, or you can do synthetic method, or you can even use grouping. But grouping does not work all the time, so we're going to use the concept of synthetic method to try and factorize this one. So the way you do this is you first of all try by using trial and error to guess the first factor there, right? So what you simply do is you're going to say let f of x, right? Let's let that expression be f of x. So f of x is 2x cubed minus x squared plus 13x minus 6, right? So the first factor, we find it via trial and error by looking for an x value that we can substitute for x there such that this whole thing becomes 0, because that will then mean the remainder is 0 according to the factor remainder theorem. So we look for an x value, we can substitute here, right? That will give us a remainder of 0. Then that x value will be the root of our first factor there, right? So you do so by starting first of all with plus 1. So you substitute plus 1 here. You substitute 1, and then you compute that in your calculator and try to see what is the answer that you're going to get. If you don't get 0, you then go back and change and put minus 1 here to see if you substitute minus 1, do you get an answer of 0. The answer here at the end must be 0. If it's not 0, you keep changing. You go to 2, and then minus 2. Then you go to 3, and then minus 3. So it turns out that on this one, we are going to get 0 when we substitute our x value as positive 2. Right? So if I sub 2 here, and I sub 2 here, and I sub 2 here, and I sub 2 here, f of 2 will simply give us a solution of exactly 0. So when we get an answer of 0, therefore, we can then conclude that it means that x minus 2 is a factor of this particular expression that we're dealing with here. And that's going to be my first factor. So I'm going to put it here as x minus 2. You're probably wondering, why am I calling it x minus 2 while we were substituting positive 2 in our x value then? Well, think about it. When we have x being replaced by plus 2, that plus 2 is what we call the root. And if you take this back, you're going to get x minus 2 is equal to 0. That means this one is a factor. So don't confuse a factor and a root. So that 2 that you're substituting there is the root, but the x minus 2 is the factor. So that's why I'm always having x minus 2 there. So whatever you have here, the factor versus the root, they will always be opposite in sign. If you're substituting a positive number, you'll have minus here, x minus. And if you're substituting a negative, you'll have x plus all the time as your factor there. Right. Now I've got my first factor and I want to find the missing 2 factors. I want to find the missing 2 factors. Of course, it looks nice and easy because you're probably wondering, why don't you just continue with this trial and error business and try 3 and minus 3 and try 4 and minus 4 and try find all those other factors using trial and error, but we're not allowed to do that. So what we need to do now is engage any of the mathematical concepts that can help us to finish this off. So the next part here, this part that I'm going to do here, right? You can use your long division here. If you don't use long division, you can use monkeys eat apples plus bananas, or you can even use synthetic. So I'm going to use synthetic to finish off this question. So what I simply do with synthetic, I'm going to put a line that looks like this, right? And then you take the coefficient. You just simply take the coefficient of your cubic expression or equation. The first coefficient is minus 2, so I'm going to have minus 2 here. The second one is minus 1, so I'm going to have minus 1 here. The third coefficient is 13, so I'm going to have 13 here. And then my last one is minus 6, so I'm going to put minus 6 here. And this root that you substituted there needs to come also and play a role, so you're going to put it there, right? You're going to put it there. So what I'm simply going to do here is a simple story. I'm going to do multiplication and addition from BODMAS. You guys remember BODMAS or BODMAS, right? I prefer calling it BEDMAS for reasons that I'll explain in one of my videos later on, right? So you are just doing two things of that BEDMAS. You're only doing multiplication and addition. You multiply, you add, you multiply, you add, you multiply, you add, until you are done with this simplification. So the first thing you do is whatever the coefficient you have here, you always put it here. You put down this coefficient of -2 as your starting point. So that -2, I'm going to come and write it here. If it was a +1, whatever you have here, you just drop that down and put it here. You begin with it, right? When I'm going this way, I'm going to multiply. So if I go this way, I multiply all the time. You're going to multiply when you're going that way. So multiply and add. Multiply and add. Multiply and add. Right. So let's see what will happen now. -2 multiplied by 2 gives us -4. Right. -2 times 2 gives us -4. That -4, I'm putting it here on top of this -1. Right. After multiplying, I'm now going to add. So you add -2 and -4 and -1, you're going to get -5. So I'm going to put that -5 here. Right. I'm done. I repeat again. -5 times 2 gives you -10, which we are going to put on top of this one. -10. -10 plus 13 gives you +3, which I'm going to put here below those guys. Once I'm done, again, I repeat. Multiply. When you go this way, you multiply. 3 by 2 gives you 6, which I'm going to put on top of this one. And then you add these ones. 6 and -6 added together will give you a value of 0. So you always need to have a 0 at the end if this thing is actually working according to the way it has to be. Right. If you don't get 0 at the end, you made a mistake either with one of the signs, or whatever you're claiming to be your factor is actually not the factor to this expression. So go back and double check if you're still doing things according to the way you are supposed to be doing them. Right. So what I'm going to do now is just finish off, because once I have those numbers, these are the coefficient. This -2, the -5, and the 3 are the coefficients of the quadratic that is going to give birth to these two factors that I'm missing there. Right. So what I'm going to do, I'm going to finish off and just say f of x is the first factor we found it is x -2. So I'm going to put that x -2 here. Right. And then the next one is going to be -2x squared that you guys see here. This -2 is going to be the coefficient. So I've got -2x squared, and then I have -5. So I'm going to put that -5 with an x, and then my last term is a 3 there. So I'm going to have that +3 at the end. And those are just simply the coefficients of the quadratic that I have there. And then I finish off by factorizing, of course, x -2. This factorizes to 2 brackets. This is going to be -2x multiplied by x, which is going to give us that -2x. I need factors of 3, so I'm going to have 3 here, and I'm going to have 1 here. And it turns out that they both need to be positive. So that's going to be plus here, and that's going to be plus. And those are the factors of f of x.